Welcome back to this tutorial series where we are making an action RPG similar to the Legend of Zelda series. Last time, we animated the idle and walk sprites for the hero. This time, we will be adding some code to let the hero actually move around and also create a little area for him to move around in. First of all, before we do anything else, just some bookkeeping here. Right now, the project is not very well organized. I'm going to create an assets folder to hold the raw assets that we're using in the project, and a separate folder to hold the code related to the hero. And we'll move the hero in there along with Tileset, which is a new asset which we'll look at later. We'll probably be changing this organization later as well. I'm also going to go into the hero's code and remove some of the hacks that we used to test it out. So I'm getting rid of the tool keyword, and I'm also going to make facing and movement normal variables. Now, in order to test out the hero's movement, the hero needs a space to move around in. So let's create a scene for the hero to inhabit. We'll call this test room. The root node will be a 2D scene, instance the hero, and also right now the camera is attached to the hero. However, I don't think we want it as part of the hero's scene because there might be cases where we don't want the camera attached to the hero. So I'm going to delete the camera here, go back to our test room scene, and I'm going to attach the camera to the root node. Add a new camera, make it the current camera, and let's reduce the zoom a bit. This way, the camera is not fixed to the hero, so when the hero moves around, we'll be able to observe that. I'm going to create a child node of the hero, which will be used to control its parent. We don't need anything special for this, so let's just get a regular node, call it controller, and we'll attach a script. For now, the controls that we want are when you press left, right, up, or down, the hero will move in the appropriate direction, and when you're not pressing one of those buttons, the hero will not move. So what we're going to do is on every physics frame, we are going to check what the player is pressing. I think probably the best way to handle this is going to be to just build up a direction vector. Direction equals an empty vector 2. Now let's see if the left button is being pressed. So if input dot is key pressed, and then the left key is key left, then we're going to subtract one from the x component of the direction. Likewise, if input dot is key pressed right, we will add one, and we'll do the same for up and down. There we go. So if you're pressing left and right at the same time, then the x component of the direction vector will be 0. But if you're only pressing one of them, then you'll move in that direction, which is, I think, what we want. Then there's just one more choice to make, which is should we normalize the vector or not? Normalizing means if you're moving diagonally, you would be moving at the same speed as you would moving horizontally or vertically. I think for now, let's not bother with that. It's easy enough to add if we want it later. We've computed the direction, and now we need to translate that into motion for the hero. If we go back and look at the hero's code, we are currently setting the hero's facing and movement based on these two variables. In addition, we also want to actually move if movement is playing. So what we'll probably want to do is add a speed constant, walk speed, and let's just set it to 100 for now. We'll also add a velocity variable. So then in physics process, what we can do is we can just say velocity equals move and slide velocity. Since the hero is a kinematic body 2D, we can use move and slide to get collisions with walls and sliding along walls for free. Now, we could have the controller directly manipulate the player's velocity. It would be better to have a function which the controller can call so that we have a better idea of which of these variables are being exposed to be manipulated outside. Let's create a function called walk. And when we call walk, we give it a direction, which is a vector 2. We'll set velocity to be equal to direction times walk speed. Then if we go back to the controller, we can just say get parent dot walk in direction. Here's our hero, and as you can see, we are moving around, but the move animations that we implemented last time are not showing up. And of course, the reason they're not showing up is because we are not setting facing or movement. So the first thing we want to do is set movement to be walk when we walk. So we'll say movement equals walk. Now the facing is a little bit trickier because we are able to move diagonally. So in order to determine the facing, we will check whether the x component of the direction is greater than the y component. So if direction.x greater than direction.y, we will set the facing to be along the x-axis. So facing equals, the first thing we're going to do is we're going to snap the direction vector to the vector pointing along the horizontal axis. Then we're going to normalize it, which will give it a length of 1. If you're curious about what snap does, the documentation says it returns the vector with each component snapped to the nearest multiple of step. Oh, which means actually if it's snapped to the nearest multiple, then we probably don't need to normalize this, actually. The nearest multiple of vector 2.right is of length 1. If that isn't the case, then we will instead snap it to vector 2.down, since down is the positive direction. All right, so as you can see, our hero is now able to move with the appropriate animation being added. However, you may have noticed that when we stop moving, the animation continues. And of course, that is because we are setting movement to walk, but we don't set the movement back to idle anywhere. But this is easily fixed because if the direction is 0, remember 0 would be if we're not pressing a key, or if we're pressing, say, left and right at the same time, then we stop moving. So all we have to do is say if direction equals vector 2.0, then movement equals idle, else just what we have already. Oh, and this needs to be a double equals. Okay, it's still not working. So if we go back and look at the code, all right, when we set the texture, we're matching based on the facing. And if we look at this, we're setting facing to the snap direction. And of course, if the direction is 0, then the facing is going to become 0, which doesn't match any of these. We probably only want to change the facing if the direction is not 0. So let's move all of this into here. And there we go. The hero moves and stops moving. If we look at this, the diagonal movement is noticeably faster than the orthogonal movement. So let's just go ahead and fix that the way that we talked about earlier. We can just go in here and normalize the direction. And again, normalize just means the vector is scaled so that it has a length of 1. And now the hero is moving and the diagonal motion seems a lot better. Now, it's a little boring just having the hero running around this void, so let's add some tiles. I found a great tile set by runninblood on itch.io. There's a link in the description below. It is very similar to the classic Legend of Zelda tile sets, but also a little bit different. And what we're going to do is we're going to set up auto-tiling. First, we create a new resource, a tile set. We will just call it tileset for now. And then we drag and drop our tileset image in here. And now we want to create an autotile. For the moment, let's just create a nice little grass region here for the hero. So new autotile. And right now, okay, this isn't quite right. So the tile, we're going to call it grassland. We need to set the subtile size to 16 because these are 16 by 16 tiles. And then up here, I'm going to enable snap, and we're going to set the snap grid size also to be 16 by 16. So now let's zoom in a little bit here. To reselect the region, we will select this. So the idea behind auto-tiling is we have a contiguous region made up of the same type of tile, and the auto-tile will select the right tile based on the tiles around it. And the way that we do this is using a bit mask. We want, let's just go 3x3 minimal. And the way the bit mask works is for each tile, you can fill in up to 9 of these spaces. The center space represents the tile, and the 8 other spaces around it represent the neighboring tiles. So, for example, for this central tile, if we fill in all 8 of those dots around, it means that the center tile is only placed if there is another auto tile of the same type on each of the 8 surrounding tiles. Whereas for this tile up here, we're only going to add an auto tile if the tiles on the left and right and the 3 below it are filled in. Likewise, this one is only the 3 tiles to the right and below it, and so on and so forth. So this just looks like this. And then we can fill in other parts as well. It looks like these do continue above and below. Let's do that. And there we go. That is a full tile set for the grass region. We're going to need to add a tile map. And then we drag and drop our tileset resource into the tile map. I'm going to close the asset so that's not confusing. And now if we look at this grassland, you notice that the icon is not grass. That's because we forgot to set the icon. So let's just go do that really quick. So you can do that with icon. So right now it's whatever's in the upper left corner of the region, but obviously that's not something we care about. So let's just set it to be this, which is what you get if you have a single grass tile. Returning to our scene, let's move this tile map to up here so that it appears below the hero. Right now you can see these look a little odd, and that's because the cell size is set to 64. So we're just going to set that to 16. Now we can just paint with this, and the auto tile will calculate which tiles should be placed in each location. And as you can see, there's sometimes some weird parts where well, maybe I missed some of the tiles. So I'll go back and fix that later if I got some of the bit masks wrong. But for the most part, it seems to be good. And there we have it. We now have a hero who can move around and some tiles for him to move around on. Of course, right now it isn't very much of a challenge. There are no obstacles. So next time we'll be adding obstacles, and we will also be adding the ability to jump over said obstacles. Thanks for watching. Okay, there are 2 corrections that I need to make. Fortunately, I haven't posted the video yet, so I can just add these to the end. So to start with, I figured out the little bit of weirdness with the tile set. I had forgotten some bits for the bitmap here and here, and because of that, if I draw a region here where there's a tile with neighbors up and to the right, and to the left, there was no tile for that. And the default behavior, if there's no tile that matches, is to just use whatever the icon is, which in this case is the single tile. So once I add these bits again, that is fixed, although I do have to repaint it. The other issue is with part of the script for animating the hero. Specifically, in the walk function, I compared direction.x to direction.y, and eagle-eyed viewers may have noticed that this isn't actually the absolute value of this. So if we're looking at movement to the left, x would be negative, even if it has a greater magnitude than the magnitude of y. So that's easy enough to fix using absolute value. You might also be wondering why this still worked. And that has to do with the second issue, which is that I should really be using project, not snap. Snap does not do what I thought it did. I thought that it projected the vector onto another vector, but actually there is a different function called project, which literally does that, returns this vector projected onto vector B. And so what was happening was we were getting facings that did not match any of these, and so the character just continued its previous facing. But this is easy enough, so project, and then we do need to normalize it in this case. So now I can press 2 buttons at the same time, and the character behaves as expected. So just wanted to make sure that I corrected those mistakes.